A man in Southampton, England, cardiac arrest, flatlined, clinically dead for 3 minutes. Later described the exact movements of a nurse he had never met, the specific words a doctor spoke, and the two bleeps from a machine that confirmed his heart had restarted. His brain had no blood, his EEG showed nothing, yet he heard everything. In 2020, researchers at the University of British Columbia proved what hospice workers have whispered for decades. Your auditory system keeps processing sound long after your body has stopped responding to the world. The assumption is clean and simple. Heart stops, blood stops, brain stops, you stop. Everything, vision, touch, smell, taste, hearing, gone, simultaneously, like a television unplugged from the wall. This assumption is wrong, not philosophically wrong, empirically wrong, measurably, documentably, repeatably wrong. Your senses do not shut down together. They fall like dominoes in a specific sequence. Touch fades first, then vision. Your visual cortex is extraordinarily hungry for oxygen and glucose, consuming nearly 20% of the brain's total energy budget, despite occupying only 10% of cortical volume. When blood stops flowing, it dies fast. Smell and taste follow. But hearing, your ability to detect, process, and neurally respond to sound, persists. Not for seconds, for minutes. In some documented cases, far longer. Elizabeth Blundon and her team at the University of British Columbia published their findings in Scientific Reports in June 2020. They placed EEG caps on actively dying hospice patients, people in their final hours of life, completely unresponsive to touch, voice, or visual stimuli, and played them sequences of auditory tones. The results were unambiguous. These dying brains were not merely registering sound passively, they were discriminating between different tones. They were detecting patterns. Some showed brain signatures associated with conscious awareness of what they were hearing. Their auditory systems were still online. Their brains, supposedly shut down, were still listening. But the question that keeps neuroscientists awake is not whether this happens, it is why. What possible purpose does a dying brain have for maintaining its hearing when everything else has already gone dark? To understand why your hearing persists after death, you need to understand how radically different your auditory system is from every other sense you possess. Your eyes need light. Your skin needs pressure. Your tongue needs molecules dissolved in saliva. Your nose needs airborne particles landing on specific receptors. Each of these systems requires an external stimulus to physically reach the receptor, and each receptor requires substantial metabolic energy to maintain its readiness. Your ears work differently. Sound is mechanical vibration. When a wave of compressed air reaches your eardrum, it vibrates a membrane thinner than a sheet of paper. That vibration passes through three tiny bones, the malleus, incus, and stapes, the smallest bones in your body, each barely larger than a grain of rice. These bones amplify the vibration and transmit it to your cochlea, a fluid-filled spiral the size of a pea, buried inside the densest bone in your skull, the petrous bone of your temporal region. Here is what matters. The cochlea is passive. It does not require active metabolic input to receive vibration. The fluid inside, endolymph, transmits waves mechanically, the way a pool transmits ripples. Your hair cells, 15,000 of them arranged along the basilar membrane, bend in response to these waves. They convert mechanical motion into electrical signals, and this conversion is astonishingly energy efficient. Think of the difference this way. Your visual cortex is like a factory with 1,000 machines running simultaneously, lights blazing, motors humming, consuming massive electricity every second. Your cochlea is like a wind chime. It requires almost no energy to respond. The wind does the work. The chime just rings. This is why your hearing survives when other senses do not. When your heart stops and blood flow ceases, your visual cortex, that power-hungry factory, shuts down within seconds. 10 to 20 seconds of oxygen deprivation, and your neurons start failing. But your cochlea continues to transduce sound mechanically, even without fresh blood supply, because its initial response mechanism does not depend on active metabolism the way your retina does. Research from the Brainstem Auditory Evoked Response (BAER) literature confirms this. Studies dating back to the 1980s show that in brain-dead patients, the earliest component of the auditory brainstem response, wave 1, generated by the auditory nerve itself, sometimes persists even after all higher brain function has ceased. The ear is still sending signals. The question is whether anything upstream is still receiving them. And that brings us to Borjigin's 2023 data from the University of Michigan. Because what she found suggests that the answer is yes. Stay with me, because what happens next in your dying brain is something no neurologist predicted. In 2023, Jimo Borjigin's team at the University of Michigan monitored 4 comatose ICU patients as life support was withdrawn. 2 of those 4 patients showed something extraordinary. As their hearts stopped, as blood flow to their brains ceased, a massive surge of gamma wave activity erupted in their posterior cortical regions. Specifically, it appeared in the temporal parietal occipital junction, the temporal cortex. That is where your primary auditory cortex sits, area A1. The first place in your brain where sound becomes perception. The gamma surge was not random neural death. It was structured, coherent. Cross-frequency coupled with theta waves, a signature associated with memory encoding and conscious processing in healthy, awake brains. And it occurred in the exact region where your brain processes what it hears. If you have ever sat beside someone dying, if you have held their hand and spoken to them while machines showed nothing, while nurses said they could not hear you, this research suggests something that should stop you in your tracks. Your dying loved one's auditory cortex may not merely have been passively receiving sound. It may have been actively processing it at a level of coherence exceeding normal waking consciousness. Sam Parnia's AWARE 2 study, published in Resuscitation in September 2023, reinforces this. His team studied 567 cardiac arrest patients across 25 hospitals in the United States and the United Kingdom. Of those who survived, 40% recalled some degree of conscious awareness during the period they were clinically dead. And the most consistent element of their recall, more consistent than visual experiences, more consistent than the reported sensation of leaving their body, was hearing. They heard doctors, they heard nurses, they heard the specific words spoken over their bodies. Some scientists dispute whether these reports constitute genuine real-time perception versus reconstructed memory. The debate is legitimate. But Parnia's EEG data showed something harder to dismiss. Brainwave patterns associated with higher mental function, gamma, alpha, and beta activity, returning to normal or near normal levels up to an hour into CPR. An hour. 60 minutes after the heart stopped pumping blood. If you find this useful, if this is reshaping how you think about what dying people experience, subscribe now. Because what I am about to explain is why the auditory system receives this preferential treatment from your dying brain. The evolutionary reason. And it connects to something far deeper than survival. Depending on who you ask, the persistence of hearing at death is either an evolutionary accident, a quirk of neural architecture, or it is something far more purposeful. A final window that your brain deliberately keeps open. The evidence increasingly supports the second interpretation. What almost nobody talks about is the anatomy of why hearing is the last sense to survive, and what that anatomy reveals about your brain's priorities during death. Your auditory pathway is the shortest sensory route to your brainstem. From cochlea to auditory nerve to cochlear nucleus, 3 synapses and you are already in the brainstem. The brainstem is the oldest part of your brain. It evolved 500 million years ago. It controls your breathing, your heartbeat, your arousal state, and it is the last structure to die. The brainstem sits at the base of your skull, fed by the vertebral arteries, a separate blood supply from the carotid arteries that feed your cerebral cortex. When cardiac arrest occurs, the carotid supply fails immediately. Your cortex, your thinking brain, starts dying within seconds. But the vertebral supply, feeding your brainstem through the basilar artery, can maintain residual flow slightly longer due to its anatomical position and lower metabolic demands. This means your auditory brainstem, the relay station between your ears and your conscious brain, continues functioning after your visual cortex, your motor cortex, and your prefrontal cortex have already gone dark. Your brain is not randomly preserving hearing. It is architecturally designed so that hearing is the last system standing. But here is the part that no textbook explains adequately. In Blundon's 2020 study at UBC, Dying patients did not merely show automatic brainstem responses to sound. Some showed P3B waves, a specific electrical signature generated in the cortex, not the brainstem, that is associated with conscious detection of meaningful auditory targets. Not reflexive processing, conscious awareness. In a brain that should have been incapable of consciousness by every standard model of neurology. Read that again. Dying patients, hours from death, completely unresponsive, showed neural signatures of consciously hearing and understanding sound patterns. How? If the cortex is shutting down from oxygen deprivation, how is it generating signatures of conscious auditory processing? One hypothesis, and the research is still evolving on this, is that your dying brain redistributes its remaining resources. As systems fail, the energy that was maintaining your visual processing, your motor planning, your executive function, all of it gets redirected, concentrated, funneled toward the one sensory channel that still has an open pathway to the brainstem, to the structure keeping your awareness flickering alive. Your brain, in death, makes a choice. It cannot maintain everything, so it maintains hearing. It sacrifices vision, touch, movement, smell, and pours whatever remains into keeping one window open, one channel through which the world can still reach whatever consciousness persists. The evolutionary logic may be simple. For 500 million years, sound was the primary warning signal for danger. Your ancestors survived because they could hear predators in the dark, hear approaching storms, hear the cries of their offspring. Sound required no light, no contact, no proximity. It traveled through walls, around obstacles, across distance. Of all the senses, hearing was the most likely to save your life at the last possible moment. Your dying brain may be performing its final evolutionary function, listening for the signal that says, "Not yet. Hold on. It is not over." If your hearing persists after your heart stops, if your brain maintains auditory processing as its final act, then how you prepare this system and what you choose to put into the ears of the dying matters profoundly. Here is what the research supports. First, if you are with someone who is dying, keep talking to them. This is no longer folk wisdom, it is neuroscience. Blundon's 2020 data from UBC demonstrated cortical responses to sound in patients who had been unresponsive for hours. Speak slowly, use their name, say what you need to say, the words you have been holding back. Their auditory cortex may be processing your voice with greater clarity than you imagine. Research suggests familiar voices produce stronger neural responses than unfamiliar ones, even in unresponsive patients. Second, protect your own hearing now, while you are alive. This is not vanity. If your cochlea is damaged, if your hair cells are degraded from decades of noise exposure, then your auditory system's ability to function during low oxygen states may be compromised. The 15,000 hair cells in each cochlea do not regenerate. Every loud concert, every power tool without protection, every year of earbuds at maximum volume permanently reduces the hardware your dying brain will depend on for its final perception. Keep noise exposure below 85 decibels. Wear protection. Get your hearing tested annually after age 55. The audiologist is not just checking your convenience, they are checking the integrity of your last remaining sensory window. Third, practice auditory attention daily. Your auditory cortex, like any neural system, strengthens with use. Listen to complex music, not as background, but actively. Follow individual instruments. Detect pattern changes. This is not recreation. This is training the neural pathways that your brain will preserve longest. Research from Northwestern University's Auditory Neuroscience Laboratory, led by Nina Kraus, has demonstrated that active musical engagement strengthens the neural encoding of sound and slows age-related auditory decline. 15 minutes daily, active, focused listening. Fourth, create your auditory environment for death in advance. This is practical, not morbid. Tell your family what you want to hear. Specific music, specific voices, specific words. Write it down. Put it in your advance directive alongside your medical wishes. If your brain's final conscious experience is auditory, if hearing is genuinely your last perception of this world, then what fills your ears in those final minutes is arguably the most important sensory experience of your entire life. Fifth, reduce chronic inflammation that damages your auditory nerve. Omega-3 fatty acids, 1,000 to 2,000 milligrams of DHA daily, have been shown in a 2014 study from the American Journal of Clinical Nutrition involving 65,215 women to reduce hearing loss risk by up to 20% in adults over 50. Your auditory nerve must remain viable for your brainstem to receive any signal at all from your cochlea. Protect the nerve. Protect the pathway. If even one of these steps was something you had never considered, hit like. It tells the algorithm to show this to more people who need to rethink what dying means. Here is what we know. In 2020, researchers at the University of British Columbia proved that unresponsive dying patients show cortical brain responses to sound, including signatures associated with conscious awareness. In 2023, the University of Michigan confirmed that dying brains produce surges of structured gamma activity in auditory processing regions. And Sam Parnia's AWARE-2 study documented that 40% of cardiac arrest survivors recalled hearing events during their clinical death, with EEG evidence of higher brain function persisting up to an hour after their heart stopped. Your brain does not go dark all at once. It goes dark in stages, and it fights with everything it has to keep one channel open, the channel of hearing. The oldest sense, the most efficient sense, the sense that your brainstem refuses to release even as everything else falls away. Nobody can tell you what your brain does with what it hears in those final minutes, whether it integrates it, whether it understands it, whether the consciousness processing that sound is anything like the consciousness you experience now. But the hardware is active. The signals are being received. Something in your temporal cortex, in your brainstem, in whatever remains of your awareness, is still listening. I want to hear from you. Drop a comment. If you could guarantee that one voice would be the last thing your brain processed, whose would it be? The dying do not leave in silence. They leave still listening. Share this with someone who lost a loved one and never said goodbye. The science says their goodbye may still have been heard. And if you have not subscribed yet, you should. What comes next examines what your brain does with what it hears in those final moments, and where that information goes when the last neuron falls silent. Your final sense is not sight, it is sound. And sound never required your permission to enter.